You already know from the study of blood that you have 5 liters of blood in the human body. You learned in this chapter that you have 60,000 miles of capillaries in your body. To give you a comparison, the United States from coast to coast is just over 2,000 miles. So if you laid all your capillaries out end to end, they could go back and forth across the country about 30 times. That is a lot of capillaries. You don't have enough blood to fill all of your capillaries at the same time. So you have local blood flow. Local blood flow is how you distribute this blood through your body. Your goal is to achieve adequate perfusion. This means that you meet the needs of each tissue in your body. There are 3 things that determine how much blood goes to each tissue. So now we can look at these 3 factors. The first one is degree of vascularization. This is how many blood vessels are in a tissue. The top picture shows low vascularization. As you can see, there aren't very many blood vessels, not very many capillaries in this tissue. So this tissue would have low blood flow. These would be tissues that have low metabolism. Since they have low metabolism, they don't need very much blood flow. Examples of this would be your tendons and ligaments. If you've ever had a sprain, you probably know that those take a very long time to heal. A damaged tendon or ligament can take about 6 months to heal. The reason for the slow healing is this low degree of vascularization. The blood supply to tendons and ligaments is so low that it takes them several months to heal. The bottom picture shows a high degree of vascularization. This would be to tissues that have a high metabolism. So this is high blood flow for high metabolism tissues. Examples of this would be like your brain, your heart, your skeletal muscles. Your body is always adapting. You can change your degree of vascularization. Okay, let's suppose that you have been sedentary and you suddenly start exercising. You would add more blood vessels to that tissue. Or if you've been exercising and then you become sedentary, you would lose blood vessels to your skeletal muscle tissues. Another factor that can cause change is cancer. So we know that it can change based on your activity level. Cancer can also change. New cancer tumors cause angiogenesis. Angiogenesis means you're forming new vessels so that you are increasing the degree of vascularization. So somebody gets cancer and they have a tumor. That tumor needs a lot of blood flow. It needs oxygen and nutrients. So the tumor will induce angiogenesis. It will force your body to grow new vessels to feed it. One of the research areas in treating cancer is to try and stop this angiogenesis. If you can stop that, you could starve the tumor. Okay, another factor is local control. Capillary beds can open and close. The top picture, you can see that the capillary bed is open. And in the bottom picture, you can see that the capillary bed is closed. There are muscles. Notice these little muscles here? Those are muscles that can open or close the capillary bed. These muscles are triggered by the amount of waste. So think about this. Cells have metabolism. And through their metabolism, they produce waste. Okay, the higher the metabolism, the more waste. As the waste builds up, it stimulates those muscles to open the capillary bed. Then blood flows through, cleans out the waste. Now the waste level is low, and so the muscles close the capillary bed. This way, you're always getting just the amount of blood to a tissue that it needs. When a tissue is resting, doesn't make very much waste. So it's going to have a low blood flow. When a tissue is active, it will make more waste. And now that waste will stimulate these capillary beds to open more often, and you will have high blood flow. So this is how you adjust blood flow to always meet the needs of that particular tissue. Our third factor is total blood flow. Think of this like the cardiac output that you already learned. This is the amount of blood that the heart is pumping. The more blood that the heart pumps, the more blood each tissue receives. Think of it like pizza. If I said I was going to give you a pizza and you were to get 25% of that pizza, if I bring in a large versus a small, you'll get more. The bigger the pizza, the more you will get. It's the same idea with blood flow. The faster and harder the heart is pumping, the more blood is sent to the entire body.